Hey everyone, welcome to Lowell Observatory's live stream on the Lyrids Meteor Shower. I'm super excited to be doing this tonight with you guys. My name is Megan Gialluca. I'm a research assistant here at Lowell Observatory. And of course, I work in the wonderful wide field of meteor science. And I'm going to talk a little bit about the project that I work on specifically here at the observatory at the end of the presentation that I'm going to give. Now, some of you may know my co-host in the past, Dr. Nis Moskovitz, unfortunately couldn't join us tonight. So I am doing a Lowell Observatory live stream takeover. Now up on your screen, you should be able to see the DCT all-sky camera. Super cool. It's showing the all-sky camera live right now at the Lowell Observatory's Lowell Discovery Telescope research site. Now, throughout the night, we're going to be able to keep an eye on this and look for actual meteors happening right now. Well, I guess there'll be a couple minutes in the past once we see them, but essentially right now, tonight. Just some things to point out on the all-sky camera. Obviously, you have your directions, north, south, east, and west, pretty clearly labeled in bright teal, I guess would be the color. Right in the middle of the all-sky camera right now is the moon. It's super bright and in our way, and we're going to talk about that too and how that affects meteor shower viewing. On the right of the all-sky camera is the LDT, so you can see it just sort of popping right above the western horizon. You may see that move around as the night goes on. I'm not sure if anybody's viewing on it or not. And other than that, there's not too much to see. So conditions tonight are good, but they're not great. We have a super bright moon tonight on its way to being full, but not quite there yet. So hopefully that won't bother us too much, and maybe we'll see a couple of meteors. So throughout this live stream, please post your questions in the chat. I will take them on an ongoing basis. I have friends of mine at the observatory who are helping me to monitor the chat so I don't miss out on anybody's questions. But for now, I think I'm going to take it over to a little PowerPoint I have created to talk about tonight. Okay, I'm pulling it up now. Perfect. And presenting. So I'm hoping everybody can see my PowerPoint. I am going to go ahead and start talking about it, but my friends at Lowell Observatory, if you can't see it, just let me know. Okay, I'm getting the looks great sign, so I think we're good to go. So the Lyrid Meteor Shower, what is it? What's its history? Why do we care? So before we jump into the Lyrids specifically, I think it's really important that we all get on the same page with terminology. And this is something that, for my friends that have been at lots of our meteor shower live streams, I'm sure you're sick of the terminology by now, but it's important, so we're going to go through it anyways. So meteor terminology, this graphic that you see on the right side of your screen, phenomenal graphic. It was published by the American Meteor Society, specifically created by Vincent Perlerin. So if you ever need a little reference guide, definitely try to find this graphic. Just because it can be a lot of information at once, I'm going to go things a little bit more slowly with everyone. So right off the bat, you have three terms that are going to be super important. There we go. Okay, so I've highlighted them on the graphic with the red stars, and I've also put them up on the left side of the screen. So let's go through and talk about each one. Number one, meteor. What is a meteor? We're looking for meteors, but what actually is it? So a meteor is actually the phenomena you see in the sky. So that streak of light that you look for when you're watching a meteor shower, that is actually what we would refer to as a meteor. Now, the thing creating that streak of light isn't necessarily a meteor. That thing creating it, we would probably call a meteoroid, sometimes a meteorite. But let's figure out what the very slight difference between these two terms is. So a meteorite is, let's say hypothetically, you have a piece of debris or rock, and it comes shooting through the atmosphere, creates a streak of light, creates a meteor, but somehow it survives the super violent process and it manages to hit the Earth. That piece of rock that hits the Earth would then be known as a meteorite. So only if it survives its meteor phase and lands on the Earth would we call it a meteorite. So what is a meteoroid? Well, I'm sure you could guess based on what the other two definitions are, but a meteoroid is the piece of debris, the particle, or the rock that's actually in space before it gets pulled by the Earth's gravitational pull to create a meteor. So if you have this little piece of rock floating in space, looks like it might hit the Earth at some point, but we're not too sure, we would call that a meteoroid. The second it hits our atmosphere and starts creating that streak of light and burning up, that's a meteor. If it survives that violent process, that descent through the atmosphere and hits the ground, it's a meteorite. So hopefully we're all on the same page with this. Now, the next two terms we want to go through are going to be what we call parent bodies. So parent bodies are going to be things that create meteoroids. Meteoroids then create meteors, which then create meteorites. So it's a whole timeline, it's a process, everything's connected. But before I explain about the difference between comets and asteroids, which are our most common parent bodies for meteors, I have a question. Can I see them through a window? Yeah, you can see them through a window as long as it's not a dirty window. I mean, if you can see the stars through the window, you can see a meteor through the window. Now I got another question. Which direction is the shower coming from? So that's a good question, and I am going to go over that in just a couple of minutes. But you can see the shower in any part of the sky. That's the beauty of meteor showers, is you don't have to be really good at astronomy to be able to see a couple of meteors now and then. But I will go over where the meteors are going to appear to be radiating from in the sky, what we would call the radiant position. And I'll explain more about that, what that means in a couple of slides. Thanks for the questions. Let's keep them up, you guys. Otherwise, this will be a boring night for me. So comets and asteroids. These are things that create meteoroids, which create meteors, just like we talked about. And comets are going to be objects. They're going to be made of rock, iron, but ice mainly. Comets are very dominated by ice. And they typically take very, very, very long times to orbit the sun. Believe it or not, the parent body of the Lyrids meteor shower is a comet. And in fact, most meteor showers do have cometary parent bodies. I can't actually think of a meteor shower that has an asteroid as a parent body at the moment, but asteroids do create meteoroids, which do create meteors. They're just not associated with a particular shower. But anyways, comets usually visit the Kuiper belt, which is where Pluto lives, and the Oort cloud, which is the furthest part of our solar system. And now before I explain asteroids, let's go through a couple of questions. So what is the maximum height a meteor can occur? It's a very good question. And actually, it can occur at all different heights in the atmosphere. And in fact, the different compositions of meteoroids can actually cause them to burn up higher or lower in the atmosphere. So the very maybe not satisfying answer is that it changes quite frequently. And then second question, when will it start? Well, it started a couple of days ago. Meteor showers actually don't just go on for one night only. They kind of phase in slowly, last for a couple of nights. Then you hit the peak night, which is tonight for the Lyrids. And then they sort of phase out. So even tomorrow night, you'll still be able to see some shower meteors. So good question. Now, asteroids, which are the second very common parent body for meteors, are going to be objects that are typically just made up of rock and iron for the most part. And they like to hang out just between Mars and Jupiter in what we call the main asteroid belt. Or in some cases, they're in the Kuiper belt where Pluto lives. Asteroids take significantly less time to orbit the sun than comets. They're more akin to the planets like Earth. They have more circular orbits than the comets do. Comets have these very elongated orbits, which take them very close to the sun and then very far away. So one last term that I want to talk about before we move on is, of course, a meteor shower. So a meteor shower is caused by when the Earth passes through streams of meteoroids. So let's take a step back for a minute. Meteoroids, once again, these are debris or rocks, particles that are floating around in space that when they are intercepted by the Earth, they create meteors. So now imagine a comet, which comes close to the sun, starts getting really hot, starts letting off lots of material. a comet can create these long strings of meteoroids in space. And when the Earth is positioned just right that it passes through these streams, it creates a meteor shower, which is a night where we have lots of different meteors all night and just a ton. So the massive amounts of particles burning up in the atmosphere creates meteor showers. So we're going to talk about the Lyrid's parent body in just a second, which is a comet that has created a meteoroid stream, which we are now passing through at this very moment. So more questions? Megan, what is your favorite planet you want to learn more about? Well, that's a really good question. And you guys are really out to get me off topic tonight because I am actually at heart a planetary scientist. I very much like Jupiter because I think it's cool looking. But if you to really get at the heart of your question, if I was going to spend a lot of time researching a planet, it would probably be Venus because it has a super interesting atmosphere and may have been habitable at one point in the solar system's very early formation. Okay, another question. Will the debris from the shower hit our atmosphere? That's a really good question. So yes, in fact, when that debris hits the atmosphere, that is what causes the meteor. So we're sitting here right now, and of course, we're surrounded by air. There's like all these particles all around us. We don't really notice. We think this is just like nothing around us. When in truth, there are these little particles just floating everywhere. And these pieces of debris hit our atmosphere so quickly, so fast, and with such force that they actually feel friction between themselves and the air molecules that are floating all around us. And that friction is what causes these pieces of debris to sort of set on fire, you can think about it. If you really want to use a technical term, it's called ablation. But this friction causes the piece of debris that hit our atmosphere to start heating up and burning up, and that is a meteor. So another question. Sorry, the questions are coming in faster than I can field them. Okay, are fireballs associated with the Lyrids? Good question. Unfortunately, no, the Lyrids does not have a super high fraction of fireballs. This can be true with a lot of showers. A lot of showers tend to have sort of uninteresting meteors. But there's always going to be these random meteors that don't truly come from the shower every night. We call these sporadic. And these meteors are frequently fireballs. So I would not doubt for 1 second that if you spend a significant amount of time watching the Lyrids, you will see a couple of fireballs. Okay, what time's the meteor shower going to happen? We are going to go over this in some excruciating detail in a couple of slides. But I'll just say for everybody watching right now, the best time to watch is going to be after midnight, your local time. So here in Flagstaff, after midnight. On the East Coast, after midnight. Canada, after midnight. Everywhere, after midnight. And I'll explain why that is in a little bit. Cool. So I think we're all caught up. Let's keep going. Okay, so the Lyrid parent body, it is a comet called a Thatcher. Now, Comet Thatcher is what we would call a long period comet. So it takes a very long time to orbit the sun, 416 years, in fact. The last time it was on its closest approach to the sun was in 1861. So we should be on track to see that again sometime in 2200 sometime. So its closest approach to the sun actually takes it closer to the sun than the Earth is at 0.92 astronomical units. For reference, 1 astronomical unit is the distance from the Earth to the sun. So Comet Thatcher comes just a little bit closer than the Earth does. Now, at its farthest distance from the sun, Comet Thatcher is at 110 astronomical units. So about 110 times the distance from the Earth to the sun, which does bring it very far out of what many people would consider to be our solar system, way out to the Oort cloud, that is. Another question. Hey, Megan, can you explain how we are getting a multicolored asteroid shower in December? So I haven't heard too much about that, actually. It's pretty far ways off. I hope we're not getting an asteroid shower, actually. That would be very destructive for the Earth. You do not want asteroids to hit the Earth. But maybe you're thinking we'll get a colorful meteor shower in December. And then I would be thinking the Geminids, which is the largest meteor shower in December. Yeah, I know I don't have a satisfying answer to that, but if somebody told you asteroids are going to be hitting the Earth, I would maybe take that statement with a grain of salt. Another question. Is it true that the moon will be pink Monday? I know it's not about meteor showers. If the moon will be pink on Monday. Monday might be the full moon, so we're in a wax and gibbous phase right now. We're on our way to a full moon. But the moon will actually appears to be a little bit reddish every night if you catch it when it's rising. And this is getting me really off topic, but there's a phenomenon in physics called Rayleigh scattering. It's the same reason why sunsets are pretty colors and why sunrises are pretty colors. But essentially, the lower in the atmosphere an object is, the redder it appears. That's the gist of it. Another question, how do we discover comets? It seems like their long period makes them hard to spot. Yeah, that's a really good observation. Get it? Observation. Okay, but yes, that is a good observation. They are hard to spot. But there is a very, very long period of time, way back in history, when you could get really, really famous for seeing comets. They called them comet hunters. In fact, one of them was a guy by the name of Charles Messier. And Charles Messier, you might know him from Messier Objects. He would actually look for comets because he wanted to get rich and famous. And he kept finding all of these objects like the Crab Nebula and the Orion Nebula. And they found nebulae and he found star clusters. And he just kept getting really annoyed that they weren't comets. So he kept a catalog of them so that he wouldn't look at them again. And fast forward to nowadays, he's actually like one of the most famous astronomers for his catalog of Messier objects. When in truth, there was just a big old catalog that was annoying him of objects that he didn't like. Cool. Oh, so the full moon in April is traditionally called a pink moon because that was when pink flowers bloomed. Cool, thanks Danielle. I didn't know that actually. It was one of my Lowell peeps helped me out there. And I just like to stress also for any aspiring scientists, it is okay not to know the answer to a question, okay? I say I don't know all the time. It's better to say you don't know than to make up an answer. Moving on. So how old are the meteors in the shower? That's a good question. So every time Comet Thatcher comes close to the sun heats it up and it starts to release particles. And so the last time Comet Thatcher came close to the sun was in 1861. So it's a pretty good bet that some of the particles we're going to be running into tonight are from about 1861. Cool. So, okay, one more question. Have you ever seen a fireball? Yeah, I've seen a fireball. I see a ton of fireballs. I see fireballs every night I go out to look for meteors. They're a lot more common than you would think. And if you just spend some time looking up in a dark place, you're bound to see a couple every now and then, especially if you're looking for meteor showers. So let us continue on. Oh, and good question about the fireball. I'm actually going to jump back to the last slide. There were two terms I didn't talk about here, which would be fireball and bolide. So a fireball is just a term for like a very bright meteor. And the true definition is a meteor that is brighter than the planet Venus. So Venus is one of the brightest things in the sky. So if you see a meteor that is just like super, super bright, brighter than the planets that you can see, then that's a fireball. And a bolide is a fireball that explodes in the atmosphere. Okay, so we have one more question, and that is, why do meteors burn up? So I talked about this a little bit, but I'll go through it one more time just for everybody watching. Essentially, you have all of these air molecules, right? These are actual things. It's not nothing around us. When a little piece of debris hits the atmosphere full of air molecules, it hits with such speed that it starts to cause friction between the particle or the debris that fell into the atmosphere and the air molecules. This friction eventually causes the rock to sort of heat up and melt. And that is the burning up process in the atmosphere that you're talking about. So cool, we're all caught up on questions. Real quick, the all sky camera should still be up on your screen. Everybody should be able to see it sort of off to the side. And this is a camera out at Lowell Observatory's research site, the Lowell Discovery Telescope. And it is live right now showing us the sky. We have it up to see if we can catch any meteors. The moon is sort of making it hard, but we'll see what happens. Okay, so moving on, history of the Lyrids. I just have a couple of fun facts I like to point out. Number one, the background image you're seeing, super cool. It shows a Lyrid Meteor hitting the Earth's atmosphere, taken from the International Space Station by NASA astronaut Don Petit. So I just think that's super cool. We've observed the Lyrids for over 2,700 years. It was first recorded in China in 687 BC. So that makes it one of the first recorded meteor showers, very close to the Leonids. The Lyrids actually helped us find the link between meteor showers and comets. So Comet Thatcher was actually discovered before we knew that it was the parent body for the Lyrids. Essentially what happened was this guy, who I can't remember his first name, but his last name is Thatcher, he discovered this comet and he was like, whoa, this is Comet Thatcher. And then sort of simultaneously, we realized that the meteor activity at this time in April was higher. And eventually, some super smart people that are not me managed to find a link between the higher amounts of meteor activity in April and Comet Thatcher. So the Lyrids was actually one of the meteor showers that helped us figure out that they're caused by comets. And then finally, the Lyrids have been known to have outbursts. So what this means is that periodically, some years, instead of having a max hourly rate of like 20 meteors, the Lyrids will show a couple hundred meteors. So the last one of these happened in 1982 and was observed from the USA. A couple times before that, there was one in 1942, which I think was observed in Germany, and one in 1922, which was observed in China, I believe. So, keep your eye out on the Lyrids. They might surprise you some years. More questions. This is awesome. I don't think we've ever gotten this many questions this quickly. In a meteor shower live stream, that is. Okay, so what makes some meteors explode? That's a good question. And truth be told, there is a lot of active research going into that very question. We're not really sure. I mean, some people may be sure than others. I don't know too much about it, but I do have a feeling that it has to do with the composition of those meteors. That would be my best answer there. So another question. How does the moon affect meteor showers? Very, very good question. We're going to get into that extensively in like 4 slides from now. But essentially, the moon, when you're trying to view meteor showers, the moon is your worst enemy. The moon is so bright, the light that it reflects can actually drown out meteors and make it harder for you to see them. So one more question. How does smog and light pollution affect meteor spotting? Will wildfire smoke make seeing the Perseids harder? Very good question. So that's very similar to the previous question from Anthony. And the answer, let's get into that a little bit more. So anytime you have something blocking the night sky, of course, it's going to be next to impossible for you to see meteors, right? So if you have clouds out right now, I'm sorry, but you're not going to be able to see many, if any, meteors. Light pollution makes it harder, right? For people in those big cities, you know what I'm talking about. You go outside, you look up at the sky, and you can't see any of the stars. And that's just because of the sheer amount of light that people are letting up into the atmosphere. So the moon is a massive light polluter. And that is why when it's a very moony night out, it gets very difficult to see meteors. And will wildfire smoke make seeing the Perseids harder? That is a tongue twister, by the way. The answer is yes. If you are somewhere that has wildfires and they're not being properly controlled or battled, then massive amounts of wildfire smoke can act like smog and block out your view of the night sky. Okay, another question. What does meteor... what are meteors made of? I think that's what it is. So they can be made of a couple of different things. And we know this from the meteorites, the rocks that we find on the ground for those big meteors. They can be made up of rock. They can have iron. They can have different silicate materials in them, like olivine. And they can also be made up of just little particles looking like sand grains almost. We call these chondrules, and they're a part of meteorites called chondrites. Good question. So what is the oldest recorded meteor shower? So don't quote me on this. I would have to do a quick lookup to be totally confident in this answer, but I'm fairly certain it is the Lyrid meteor shower. And somebody can double check this for me if they'd like. Now, silly question, would a returning space capsule be considered a meteor, or do they have to be naturally occurring and not man-made? I like the way you think. I like that. That's funny. The answer is no. Unfortunately, a space capsule would not be considered a meteor. A meteor is very specific to a meteoroid entering the atmosphere, a small piece of rock, etc., and creating what we call an ablation process streak of light. That is funny, though. I like that. I like that a lot. Unfortunately, no. So, do these endanger the ISS? Good question. The answer is kind of, but not really. So whenever you have satellites in space, they are aware when meteor showers are happening. And in some cases, they'll take safety precautions like making sure nobody's out on a spacewalk in the ISS's case, or sort of folding in certain parts, certain equipment on a spacecraft. But in truth, it doesn't really do much. We basically take these safety precautions just in case, the one time you have a little meteoroid streak through and could potentially hit somebody or something. But these spacecrafts, they're designed to take a little bit of dust and debris every now and again. Oh, wow, Danielle. Apparently, the oldest recorded sighting of a meteor shower is the Lyrids in 687 BC. So I had it right up on the slide. I just, wasn't sure if the Leonids were beating it. Thanks for that. Thanks for fixing that for me. Okay, cool. So somebody said they saw TikTok saying tomorrow there will be a meteor shower. Yes, I have heard of that because it's this meteor shower. It's this very meteor shower we're talking about. Meteor showers don't only last one night. They typically last for about a week, if not longer. Tonight's just the peak night. Oh, and Danielle is telling me that the Leonids were discovered in 902 AD. So yeah, a couple hundred years after the Lyrids. Wow, good for the Lyrids. You learn something new every day, right? Cool, so let's move on. How do I view the Lyrids? Now, I know a lot of you have been waiting for this part of the talk, so I'm just gonna wake everybody up. We're gonna talk about how to view the Lyrids now. Everybody pay attention. What is the best time to view? I'm gonna make this really easy for everyone. The best time to view is after midnight, 12 a.m. in your local time zone. I don't care where you are. If you come to me, you say, Megan, I'm in this spot. I'm gonna say after midnight. So just so we really drive this point home, in Flagstaff, after midnight. On the East Coast, after midnight. In Canada, after midnight. In Europe, after midnight. In Asia, after midnight. Wherever you are, the best time to view is after midnight, all right? Glad we're all on the same page with that. Now let's take a quick question break, and I'm about to tell you why this is the best time to view. Okay. What is the difference between a meteor, a meteorite, and a meteoroid? Okay, so I hope I pronounced your name right. I apologize in advance if I don't. So Vinesh, I went over this in detail at the beginning of the live stream. I don't know if you can look back at that, but I'll go through it super fast for you as a recap. So a meteor is the actual streak of light that you see in the sky. A meteorite is if the rock that created that meteor survives its trip through the atmosphere and hits the ground, hits the earth, then it is a meteorite. And a meteoroid is that rock or debris or particle that is in space before it becomes a meteor. Cool, let's keep going. So why is this the best time to view? Well, you say, Megan, you tell me after midnight. For some showers, you tell me 1 a.m. Why? What is going on? So we're going to go through a classic teach a man to fish, give a man a fish, teach a man to fish sort of conundrum here. Why is it the best time? One answer, the moon. Okay, it all boils down to the moon. So very common myth, no matter what the shower is, the best time to view as early as possible, like 3 to 4 a.m. That's not true. The fact is, light pollution has the greatest effect on shower viewing conditions. And the biggest polluter in most places is the moon. So we want to choose when we're going to go out to view the shower such that we minimize the amount of light we're getting from the moon. So what do we know about the moon tonight, April 21st, 2021? Well, I can tell you that the moon is in its waxing gibbous phase. It is 69% illuminated. The rise time of the moon was today at about 1 p.m. and it's going to set tonight at about 3:20 a.m. So now you're saying, but Megan, you said the best time was after midnight. You're right, I did. In truth, if you're willing to go out at 3:30 a.m. right after the moon is set, well, you're going to have the darkest conditions, and all power to you because I'm going to be sleeping. So I added a new qualifier, which is at midnight, the moon will pass below 30 degrees altitude. So this is a very common sort of, number for a lot of astronomers. Like for instance, when I'm installing cameras that are going to be viewing meteors, I look to make sure that the camera has a clear view above 30 degrees altitude. So once the moon gets below 30 degrees altitude, its effect on you is going to be minimal, especially because the moon is going to set in the west and the radiant position, or where the meteors are going to appear to be coming from, will be in the east. So you can get up at 3:30 a.m. or stay up till then if you want, all power to you. But I'm saying that after midnight, you should get a very similar, if not the same view that you will get at 3 a.m. And my favorite website for moon info is shown right here at the bottom of the screen. Now, I just really want to drive this point home. So in a couple months from now, we'll just say the Perseids, because everybody loves the Perseids, which is in August. A couple months from now, the Perseids are going, and I don't know, maybe I just disappeared and I'm not here to tell you guys about the shower. And you're like, oh no, Megan's gone. What am I going to do? How am I going to know what the best time to view is? Go look at when the moon rises and sets and try to go out at some point where the moon is not in the sky or below 30 degrees altitude. So, sometimes the moon rises at midnight and sets sometime in the afternoon the next day. On those nights, you would want to go out before midnight. All right, so hopefully we'll just sort of get in the wheels turning and we have an idea of how to determine what the best time is to view a shower. Now back to questions for a second. How big are most meteoroids? So meteoroids can have a very wide range of sizes, believe it or not. For the most part, though, they are very small. You know it when we have a big one. For example, you could take the Chelyabinsk event that happened in 2013, where a massive meteor came and went over Russia and then dropped a giant meteorite onto Russia. So yeah, the maybe unsatisfying answer is that there is a very wide range for sizes of meteoroids, but for the most part, they're very small. In fact, I would say most meteoroids are going to be grains of sand in your mind. Okay. Some Lyrid specific information. So right off the bat, I just want to point out that this image shown in the background is of a Lyrid meteor, which was taken last night by one of Lowell Observatory's meteor cameras. One of the ones that I got to install, actually. So very, very cool. I'm going to show you lots of videos from our cameras at the end of the presentation. So even if we don't see any meteors on the LDT all sky camera, I will have some Lyrids to show you guys. So the radiant location is Lyra. Now we name showers after their radiant location. So for example, the Geminids, their radiant location would be the constellation Gemini. The Perseids' radiant location would be the constellation Perseus. So we're looking at Lyra. Now, what does the radiant mean? Well, essentially, all shower meteors from the same shower appear to originate from the same position in the sky. That position is known as the radiant. So the radiant for tonight for the Lyrids is located in the constellation Lyra. Lyra's location at midnight will be just above the horizon in the northeast, which is perfect because the moon will be in the west. So you can turn your back on the moon and pretend it's not there. Now, finally, the zenith hourly rate, the ZHR, is about 20 meteors per hour. What does that mean? Well, zenith is the term that astronomers give to the point directly above your sky, directly above you. So no matter where you are, if you look directly up right now, you are looking at your zenith. Now, the ZHR is a fancy term for how many meteors per hour can we expect from the shower on the peak night. So tonight is the peak night, and we can expect about 20 meteors per hour. On years where the Lyrids has an outburst, it can get up to 100 or more. By the way, though, this year is not an outburst as far as I know. So another question, any possibility to see these from a city, or is that going to be too much city lights? So it really depends on the city you're in and how bright it is there. I might just take a stab in the dark and say maybe you're in Phoenix. I'm in Flagstaff, so that would be my next best guess. If you're in Phoenix, I would maybe recommend that you drive just like a little bit, maybe like 30 minutes outside of the city, and you should be able to see some for sure. Even in Phoenix, you might catch the brightest meteors if there's a fireball maybe or two, but I don't know if I would really waste your time sitting outside looking for them if you're in the very heart of a big city that has a lot of light pollution. I would just try to get out of it, really, to view the shower. Where is the observatory located? I have, where is your observation located? Oh, do you mean the observation on the screen? Okay, I'll give both answers. So the observatory, Lowell Observatory, is located here in Flagstaff, where I am currently. And the location from which this Lyrid meteor was taken, I don't remember the exact station, but it was either at Lowell Observatory here in Flagstaff, or it was at the LDT meteor cameras, which are in Happy Jack, Arizona. Another question. What direction can we see the meteor shower in Flagstaff? Good answer. So I'm going to broaden that a little bit. No matter where you are, I don't care where you are, no matter where you are, the radiant position of tonight's meteor shower will be in the northeast, more east than north. You will be able to see meteors across the entire sky. So you don't need to be looking at the radiant to see these meteors. You just need to be looking up, really. Yeah, good question. Okay. So how do I find Lyra? If you are like absolutely determined and you're like, yeah, you know what? I want to find the radiant position. I can do this. Then all power to you, and I'm going to help you. So Lyra is super easy to find because it has a very bright star in it called Vega. So this right here is Vega. You can see it right here as well. So Vega makes up one of the corners of a very common asterism, a very commonly recognizable group of stars that we call the Summer Triangle. So it's made up of three very bright stars in three different constellations. At the top, you have Vega in the constellation Lyra. Down to the left, you have Deneb in the constellation of Cygnus. And then just going to be rising above the horizon at midnight is Altair in the constellation Aquila. So if you can find this triangle of these three very bright stars rising in the east tonight, then you'll know that you are looking towards Lyra. Now, I have this super cool little video that I can play that I made. All of the graphics on your screen, by the way, were created by me using Stellarium, which is a free software that you can use to see what's in the night sky and figure out where things are. If you want to learn the constellations, I 100% recommend Stellarium. So in this video, you're seeing currently, we're going to get to midnight, and then I'll pause it. So I just paused it. This is midnight, and I'm circling where the Lyrid's radiant position is, right above Lyra. And then if we keep going to about 3 a.m., I think is the next spot I pause it at, you'll see that Lyra and the summer triangle have made their way fairly high in the sky. Yes, by 3:30 a.m. Cool. So I hope everybody feels comfortable finding Lyra now. I'll leave this video playing while I answer another couple questions. Comment/question. Could we humans launch some grains of sand sized material into space and make the best fireworks show in history? That's funny. I like where you're coming from, actually. You know what? There's nothing saying we can't do that, but it might be a lot of money, and maybe it would be cheaper to just buy fireworks, and probably would be a better show because, you know, you can make fireworks look like cooler, I think. I mean, I shouldn't say that, but yeah. In theory, if you were to put like tiny little grains of like dust and sand right above the Earth, and then we flew into it, then yeah, that would create meteors. But I think it's against the whole spirit of the thing. Okay, moving on. Oh, mythology of Lyra. So I am super excited to be talking about this. In the past, all of these live streams on meteor showers, you know, we've had guests, we've had lots of us, there's been a lot of us talking. And I don't think I've ever really gotten a chance to do mythology with you guys. So I'm really excited for this live stream because I'm going to tell you the story of Lyrid the Harp. So before I get started, you know, I am a research assistant. I'm graduating next week with my degree in astronomy and physics. I'll be attending the University of Washington in the fall, pursuing a doctorate there. But my area of expertise is by no means mythology or history. So I think it's really important that I tell you guys where I'm getting this information from before I tell you the stories. And that is from this awesome book. It is Constellation Myths as Directly Told by Aristophanes and Hyginus with Aratus' Phenomena. These guys were super, super awesome philosophers back in ancient Greece and other places in some cases. In fact, Aristophanes was actually one of the keepers of the Library of Alexandria, I believe. But anyway, so these guys are seriously directly from the source Greek mythology and constellation. Now, of course, I have to supplement this with some other sources, which are typically online sources, but the truth in the myths themselves comes directly from this book, which is a very good source. I would recommend it to anybody who wants to learn more about the constellation mythology. So with the cool, let's talk about our sources stuff out of the way, let's get into the stories. So Lyra the Harp. Lyra the Harp is believed to have been created by Hermes. And he did this with a tortoise shell and some of Apollo's cattle. He used 7 strings to represent the daughters of Atlas in most cases. And of course, there are some certain differences and tweaks in different accounts of these stories. But essentially, a lot of people believe that Hermes created Lyra, and after stealing some stuff from Apollo demanded that Hermes give him Lyra, credit him with Lyra's invention, and in return, Apollo gave to Hermes a staff. It was supposed to be a staff of peace. And Hermes was walking around one day and he saw snakes entangled together. And when he touched them with the staff, they immediately let go of each other. And that's actually why you see in this medical symbol, you see 2 snakes wrapped around it. It's supposed to represent that staff that was given by Apollo to Hermes, and that Hermes was able to disentangle these snakes by using the staff of peace. Now, this is sort of besides the point, so let's get on to who Lyra goes to and what happens. And there's 2 main stories, and for the life of me, I can't figure out which one is more accurate. They're both told by Aristophanes, so I guess you can take your pick and choose a story you like better. The first one I'm going to tell you is the story of Orpheus. But before I do that, I'm going to answer a question. Is the LDT pointed at the sky right now? Why is it so bright? Is that the moon? Yes. So why is the LDT all sky camera so bright? Yes, it is the moon, unfortunately. And is the LDT pointed at the sky right now? So I can't actually see while I have my PowerPoint in presentation mode. So Danielle, if you'd be able to tell me if the LDT is pointed at something right now, that would be great. And Stephen, I have some great friends at the observatory who are watching the LDT all sky camera for me. So if we see any meteors, I'll shout it out right away, stop whatever I'm doing and go over to that. But if we don't see any meteors because of how bright the moon is, then I will be showing you some videos of meteors that we took last night on the Lowell Observatory cameras. And Danielle says the shutters are closed, so it doesn't look like anybody's observing on the LDT tonight. Probably for the best. Who wants to observe when the moon is this bright anyways? Cool. So the story of Orpheus. So Orpheus was a very talented musician. He was the son of Calliope, who was one of the muses. So I believe he was part mortal, sort of part divine. Now, Hermes took quite a liking to Orpheus, as did Apollo. And so if you believe that Apollo took Lyra from Hermes, then you would also therefore believe that Apollo was the one that gave Orpheus Lyra. But if you believe that Hermes kept Lyra, then Hermes was the one that gave Orpheus Lyra. Either way, Orpheus, son of Calliope, one of the muses, gets Lyra. He decides to add 2 more strings, by the way, for the total number of muses that there are. But that's sort of besides the point. So Orpheus, he's this phenomenal musician. He plays Lyra like a dream, like nobody you've ever known. And of course, he's got lots of ladies after him. And one of these ladies, her name is Eurydice. So Eurydice falls madly in love with Orpheus, as does Orpheus with her. And they decide to get married. Now, it was a great wedding. Unfortunately, at the reception, Eurydice's dancing and dancing when she doesn't notice that there's a poisonous snake by her foot. It bites her, and unfortunately, Eurydice passes away. Now, Orpheus is so saddened by this that he plays the saddest songs you've ever heard on Lyrid the Harp. They're so sad, they bring the gods to tears. And eventually, the gods Apollo and I believe Zeus go to Orpheus and they tell him, you play such beautiful music on Lyra. I'm sure if you were to go appeal to Hades and Persephone with Lyra the Harp, they would give you Eurydice back. So Orpheus manages to find this back way into the underworld. And he travels into the underworld and he finds his way to Hades and Persephone. And in order to convince them to give him Eurydice back, he plays Lyra the Harp for them. And he sings ballads about all of the gods, except for Dionysus, who he just forgets about, because he's only half god, I guess, or half muse, and he just forgets. But that's besides the point at the moment. And Hades and Persephone are so moved by Orpheus's music that they decide to give him Eurydice back. But there's a catch. And the catch is that Eurydice must follow Orpheus out of the underworld the way he came. And Orpheus cannot look at Eurydice until they are back out of the underworld and into the mortal realm. If he looks at her, Hades decides that he's going to take Eurydice back. So you can guess what happens. Unfortunately, this is Greek mythology, of course. It's never that happy. And for people who are trying to knock me on my pronunciations, I actually did used to say it like Eurydice, but I was actually corrected by a manager at Lowell Observatory who said it's Eurydice. So what I've learned is that there's a million ways to pronounce things in Greek mythology, and that, you guys should go easy on me. So anyways, and I once again, I said at the beginning of this that I am not an expert on mythology. So anyways, moving on. So Eurydice manages to follow Orpheus almost all the way out of the underworld. But right as Orpheus steps back into the mortal realm, he realizes that he doesn't hear her behind him anymore. Well, curiosity gets the better of him and he turns around just to see her almost stepping out of the underworld. Fortunately, since she wasn't in the mortal realm, Hades decides to take her back. And then, unfortunately, Dionysus hears that Orpheus left him out of his song. And he's so angry that he sends his Bacchantes, and I know that I pronounced that wrong, so go easy on me, which are women who worship Dionysus. He basically tells them to attack Orpheus. Poor Orpheus. He really does not have it easy in this story. Now, quick break for questions, and then I'm going to tell you the story of Arion. So, is there anything like meteor storm? Good question. So meteor storms are super, super cool. Definitely like at the top of my list, like things, if I could see anything in my life, one of those things would be a meteor storm. Meteor storms are associated with particular showers. In particular, they are associated with the Lyrids shower. The Lyrids does not have meteor storms per se, but it does have meteor outbursts where we get up to a couple hundred of meteors per hour. The last one, once again, happened in 1982. So is Lyrid the Harp the reason why some harps are called lyres? That's a good question. I actually don't know the answer to that. I know that lyra and lyre is used fairly interchangeably through all of the texts that I've read. So I wouldn't be surprised if they were related in some way. But if I had to guess, I would probably guess that Lyra the harp was actually named Lyra because they're called lyres. Not sure on that though. So what is the source comet for the Lyrid meteor shower, and can we see it through Lowell Observatory's telescopes? Very good question. The source comet is Comet Thatcher. You can look it up. Unfortunately, if Comet Thatcher, let's say, was on its closest approach to the sun, you could probably see it with a very tiny telescope, let alone Lowell Observatory's telescopes. Unfortunately, Comet Thatcher right now is probably somewhere out by the Kuiper Belt, maybe the Oort cloud. It is very, very far away from us. Its last closest approach was just under 200 years ago. So that's almost half of its period. So Comet Thatcher is very far away from us right now, and it is going a little bit further before it starts to come back. Okay, another unrelated question. Why doesn't Arizona have daylight savings time? Because we're smart. I'm just kidding. So daylight savings time is actually a very old relic of farming life. I don't know too much about this, but I do know that it had to do with farming. And nowadays, we just sort of keep it because it's what we've always done. Arizona decided they didn't want to do that. I personally like it better. I think we should just get rid of daylight savings time. I think it's confusing. But that is so besides the point. Another question. I'm in the southern part of California. Where can I go to see a shower? I mean, you probably know SoCal more than I do. So anywhere that's dark enough for you to see the stars. So that's a good rule of thumb. If it's dark enough for you to see the stars, it is dark enough for you to see meteors. Okay, so one last little Greek mythology story about Lyra, and it is the story of Arion. I kind of like this story. I think I like this one better than the story of Orpheus, but we'll see what you guys think. Okay, cool. So Arion in this story was a phenomenal musician, just like Orpheus. However, in this story, he was given lyra by, I believe, Apollo, but a lot of accounts do not know how he received lyra. So, that one's still up in the air. However, Arion, this musician named Arion, he has Lyrid the Harp. And he becomes extremely rich and famous, and he travels along and he plays lyra for all different kinds of people. Now, the king of Corinth hears of Arion's musical ability, and the king of Corinth becomes a very big fan of his quite quickly. And so he requests that Arion come to Corinth and play for him. Arion, of course, agrees because he's a king and he's got a lot of money. And so Arion books passage on a ship to Corinth. Now, once Arion is on the ship and they're sailing away, the sailors, they begin talking. What do they talk about? They start talking about how rich Arion is and how famous he is and how good at music he is. And they start to get jealous. They want his riches, they want his land, they want his possessions. So the sailors come up with this plot that the next day they're going to throw Arion overboard and take all of his stuff and divide it amongst them. Well, that very night, Apollo comes to Arion in a dream because Apollo likes Arion a lot. And Apollo tells Arion of the plot, and he tells him that when this happens, wear the robes you wear when you like to play and start playing Lyrid the Harp and trust in whatever aid comes to you. So Arion, he wakes up from the stream, is like, wow, that was a powerful dream. He gets his robes on and he goes out for the day with Lyra. Well, just as you would expect, the sailors, eventually approach Arion, and I'm sure that it was a super awkward, conversation like, hey, no hard feelings or anything, but we're going to throw you overboard. We want your money. And Arion's like, okay, that's cool, but can I just play Lyra the Harp one last time? And the sailors are like, yeah, of course. You know what? Of course. So Arion starts playing Lyra the Harp, and he plays it so beautifully that it attracts a pod of dolphins to the boat. Arion sees these dolphins and he thinks to himself, this must be the aid that Apollo called for, and he throws himself overboard. And the sailors are like, wow, well, that makes it easy. But one of these dolphins, by the name of Delphinus, which is also a constellation, Delphinus carries Arion and Lyra the Harp all the way to Corinth. There, Arion meets the king of Corinth, and he tells him about what had happened with the sailors and Delphinus and the whole shebang. And the king of Corinth is so moved by this story that he decides to erect a statue of Delphinus the dolphin that saved Arion's life. Well, as luck would have it, a couple days later, a massive storm blew the ship that Arion was traveling on back into Corinth's port. And the king of Corinth is just waiting for this to happen. And he sees that the sailors have come into his port, and he runs up to them and he musters up to the best acting that he can. And he says, what happened to Arion? I thought he was traveling with you. Are you okay? And the sailors say, oh, he must have fallen overboard in the storm. It was a total accident. We don't know what happened to him. So the king of Corinth is like, okay. Would you be willing to swear this in front of the statue of Delphinus we have in our square? And the sailors are like, of course. So the king of Corinth goes to Arion, and he tells Arion to stay hidden until the next day. And the next day, after the sailors swear that Arion died in an accident, Arion steps out in front of them. And the king of Corinth, basically tells them, I know you're lying and you're about to get punished, so get ready for that. I'm not going to, go into the details here, but I'm sure us adults who know a little bit about Greek mythology can imagine what happened. And just for fun, here is a picture of Arion with Lyra the Harp on Delphinus, finding his way back to the island of Corinth. Cool. So that was super fun, and I'm really happy to have been able to talk a little bit about mythology tonight, because although it is not one of my areas of expertise, it is one of my hobbies. Okay, cool. Back to questions. So, is there a constellation to look towards looking for guidance to see the meteor shower? Good question. The constellation you're going to want to look towards is Lyra. But it doesn't really matter. No matter where you go in the sky, you're going to be able to see the meteor shower, no matter where you're looking. But if you look towards the eastern horizon, that is where Lyra is, and that is where the meteors will appear to be radiating from. Okay, another question. What is the average velocity of meteors during the meteor shower? Does it depend on the source comet's velocity and hence differs with respect to other meteor showers? Yeah, that's a very good question. And yes, the speed of meteors does differ shower to shower. I don't know the speed of Lyrids typically off the top of my head, but you could Google it super easy. It should be on AmericanMeteorsociety.org or NASA or any of these other really good sources for space knowledge. But yes, the speed will change depending on the meteor shower and even depending on if it's like a sporadic meteor. Meteors, believe it or not, are all super unique. They're like snowflakes. Some of them burn up high in the atmosphere, others burn up low in the atmosphere. Some go like super, super fast, others go really, really slow. It's all up in the air. Get it? It's all up in the air. Oh man, I'm on fire with the puns tonight, but in truth, I'm just sitting in my living room talking to myself. So that's fun. Okay, so how long will the shower last? Good question. So meteor showers are not just one night events, right? So tonight's the peak of the Lyrid, which means you're gonna see the most amount of meteors tonight than any other night. But in truth, meteor showers sort of start off slow, they get more and more and more and more, we hit the peak night, and then they start fading out. So the Lyrids started days ago, and they're going to keep going for another couple of days. It's just that tonight we'll have the most amount of meteors per hour. Good question. Another question, am I going to be able to watch it via my backyard? Yeah, you can watch in your backyard. That's where I would watch if I wanted to go out. Caveat to that, as long as you can see the stars from your backyard. Make sure you can see the stars. Okay, you said to turn our backs from the moon, right? Yes, the moon is your enemy when you're looking for meteors. Just turn your back up on the moon. Watch out, you'll get some air resistance with those earbuds. Yeah, you guys like my puns? It's all up in the air. Oh, you guys, that's amazing. Okay, more puns. You're just egging me on right now. My roommate's gonna come home and be so mad because I'm gonna be making a lot of puns for the rest of the night. Okay, so we went through mythology, pictures. Cool, update on LOCAM. So now we get to talk about what does Lowell Observatory do? Why does Lowell Observatory care about meteors, and how do we view them? So myself and Lowell Observatory astronomer Dr. Nick Moskowitz, in addition to another project collaborator named Rob Shotland and all of our host stations, we have been working on a project called the Lowell Observatory cameras for all sky meteor surveillance, or LOCAMs. Astronomers, let me tell you, acronyms are like the most important thing in the entire world to astronomers. So LOCAMs, that's a good acronym, if I do say so myself. Can I watch the shower on 22nd of April? Yes, you can. Yeah, that's close to the peak night, so you should be okay. Another question, should I be worried about tree cover, or is there gonna be enough not to miss it? So it's, it depends how much tree cover we're talking about. If you have a little bit, no big deal. And there's gonna be meteors all across the sky, but let's say you can only see like half the sky. You can only see the eastern half of the sky. Well, if a meteor happens in the western half of the sky, you're gonna miss it. But there will definitely be ones in the eastern half of the sky. So you just gotta think it out, If it's just a little bit of tree coverage though, I wouldn't worry about it at all. Cool. So back to LOCAMs. So let's get an update on LOCAMs. Did it already start? Yeah, started days ago. We're in the peak night tonight. It's going all night long. Best time to view after midnight. Best time to view after midnight. Everybody, best time to view after midnight. Cool. So update on LOCAMs. How are we doing, right? What's been going on? We started LOCAMs almost exactly a year ago. In fact, the Lyrids was our very first meteor shower live stream last year in 2020. So I'm super excited to be here on the year anniversary of Lowell Observatory doing meteor shower live streams. And it has just about been a year for the LOCAM project as well. So up on the screen right now are two of our stations. The one on the left is the one at Lowell Observatory up on Mars Hill here in Flagstaff. And who is that? Who's that gorgeous looking gal next to the station? Oh, it's me. I'm just kidding. But yeah, that's me next to the Lowell Observatory station after we installed it. And then on the right is the station that is out at the Lowell Discovery Telescope in Happy Jack, Arizona. So all of the videos of Lyrid's meteors I'm going to be showing to you tonight came from one of these two stations. And bonus, if you come to Lowell Observatory, if you come for one of our stargazing nights, maybe you sign up for a tour, or you wait until we can just have people, stopping by in the public programs again. But if you are on your way to the Giovanni Open Deck Observatory, which you can see in the background of this picture, you can look right up and see our LOCAM station on top of what we call the instrument building. And if you are at Lowell Observatory, you should be able to ask any of the educators and they'll be able to point it out to you. Did it already start? Oh, I already answered that, yes. Are you gonna take time-lapse photos of the shower? I can, if that's something, you know what, let's get a vote in the chat. See how many people want a time lapse from tonight from one of our stations. And if enough people want it, I will do that tomorrow and somehow get somebody to post it for me, one of the marketing people. So, just put in the chat, yes, or I want it, or, time lapse, yeah, just like something so we know how you feel. And I'm going to task my friends from the observatory with determining the votes and if we should post a time lapse. Cool. So when is the best time to start going outside to see them? It's pretty cold to stay out there and wait. Yes, very, very good point. I would go out at about midnight. But unfortunately, at no point in time are you going to be able to go out for like 1 minute, look up and be like, oh, there's the meteor, and go back inside. No matter when you go out, it'll probably take some time of just, waiting for you to see a meteor. But if you wait long enough, I promise you'll see one. Cool. So let's keep moving on with the LOCAM. So just again, want to highlight the 2 stations you see on your screen right now in these pictures are the 2 stations where all of the videos I'm going to show you are coming from. Okay, cool. So here is a distribution of our stations so far. So we have 1 station in Flagstaff, 1 station in Sedona, 1 station at the LDT. So I showed you the one in Flagstaff and at the LDT, the Lowell Discovery Telescope. And we have 1 station in Prescott, which is the photo that you see on the left here. It was taken by one of our project's collaborators. And then all the way here up on the right, on the border between Arizona and New Mexico, is a little marker at the Navajo Nation Museum in Window Rock, Arizona. And I am super, super, super excited to be installing a brand new station there on Monday. So this coming Monday, the 26th, I will be out at Window Rock installing our very next meteor station. And I'm super excited to be bringing the Navajo Nation into this project. And I'm hoping that we can put more stations in that nation. And then the yellow marker is showing Holbrook High School in Arizona. And we are working towards installing a station in Holbrook High School. And that's going to be super exciting because we'll get to collaborate with the students there, create projects, curriculums. And, maybe if I'm lucky, I'll get to do presentations for them as well. And while we're here, I'd like to do a shameless plug for anybody in Arizona. We are always looking for new station locations. We're going to be installing stations for like the next 2 to 3 years. I mean, this is a 5-year project, so I'd say 2 to 3 years. If you have connections at any of these nonprofit organizations, you have a really good residence that's in a nice dark area, and you want to host a low-cam station, then feel free to get a hold of one of us at Lowell Observatory and tell us, and we'll see, if things would work out. Cool. Jumping back to questions for a second. So when is the best time to start going outside to see them? It's pretty cold to stay out there and wait. Oh, yes. Yeah. Yep. I already got that one. We talked about that. So that time lapse is a yes. You would say 30 and counting. Yeah, you guys, time lapse. Okay, that makes me so excited. Cool. So I will get a time lapse. I'll create it, sometime tomorrow morning. Maybe I'll do a couple of different cameras, but either way, I'll get in touch with the folks from marketing and we'll get it posted somewhere that is easy and accessible for people to find. So stay tuned for that tomorrow. And then question, what's the best snacks and drinks to bring to watch a meteor shower? Well, I'd have to ask you a follow-up question, which would be, are you 21 and older? But just kidding. I mean, of course, if you're an adult and you want to have an adult beverage, all power to you. Me personally, my favorite snacks are chips and Muddy Buddies. Really like those. And then drinks, it's cold out there, so I would have to say like hot chocolate or hot apple cider, which is probably my favorite. Yeah, but I mean, your favorite snack, your favorite drink, there you go. Okay, another question. What are the low-cam stations for? That's a super good question, and you're getting me right back on track with my PowerPoint. Oh man, it's already 10:15. That's crazy. Where does the time go? Cool. So what are the low-cam stations for? It's a really good question. Well, basically our goal, is no meteor unobserved. We want to have total coverage of Arizona and New Mexico in the coming years. And that way we can see every single meteor coming through. And there's a number of really cool science questions we can answer with this. And let me tell you, meteor scientists, they're going to love this because we're building a database of all of these meteors we see every night. And we're able to use different astronomical techniques like parallax to actually see what the orbit of the meteor was before it hit Earth's atmosphere. We're also able to determine the trajectory of the meteor. So if we have a fireball or a super big bright meteor and we think that it's going to drop meteorites or rocks on the ground, we can actually determine where those are going to fall, and we can go get them the next day. And that's crazy cool, right? In fact, LOCAM's observations just a little while back, I think a year, maybe 2 years back, somebody can correct me on this if I'm wrong. This is before I got involved with the project, but LOCAM's observations actually helped us to recover meteorites. And now this is really important because a lot of the meteorites we find, we don't know how long they've been just sitting on the Earth for. They've been subjected to processes that take place on the Earth, like rain and wind and like all this crazy stuff. But with LOCAMs, we can find meteorites immediately after they've fallen on the ground. And in addition to that, we can determine the orbit of that rock before it was on the ground, and even in some cases determine what parent body it came from. So LOCAMs, I'm hoping, I got a lot of high hopes for LOCAMs, but I'm hoping it's really going to revolutionize a lot of meteor science. I'm actually working on a science question right now, which is something about how meteors actually explode in the atmosphere. So, lots of stuff coming, stay tuned, but LOCAMs is a big goal of LOCAMs is just data collection, big data, right? We're in this new era of science where we're able to take so much data on things, so much more data than people could ever look through. So that's, LOCAMs is doing a lot of cool stuff. Now I have lots of questions. And while, by the way, since it's about 10:15 here, I'm going to be wrapping it up soon. I didn't even think that the live stream would go for this long. So I got to say, wow, thank you guys so much for really keeping the questions coming. You're making this more fun for me. And you're making the stream, I think, more fun for everybody watching. And after I end this YouTube stream, we're going to be continuing a meteor shower watching stream on Twitch. So you can look for @Lowell Observatory on Twitch. That'll be starting at 10:45 p.m. So it's sort of like Lowell Observatory after dark. I'm going to be there, and I will be there with an educator, another research assistant at Lowell Observatory, and a very dear friend of mine, Hannah Zyga. So definitely go check that out if you want to keep hearing my voice. Cool. So another question. Do you also pretend your marshmallow is a comet when you accidentally catch it on fire? I have not in the past, but I'm going to now. So thanks for that. Oh man, I lost my place in all the questions. Okay, we got the Twitch stream. Okay, will you be able to see a decent number of meteors towards the later end? I mean, April 25th, 26th. So you will still see some Lyrids at that time. However, the shower activity is going to be really low. So I wouldn't really say that you'd be looking for a meteor shower, but there's a ton of meteors every night. Even when we're not in a shower, if you were to go out on any given night and look up at the sky for long enough, you're bound to see a couple of meteors. So if you want to go out on April 25th and 26th, all power to you. Do it. Okay. So how much are meteorites worth these days? A university in Montana was buying them 25 years ago and put out ads to buy them. Yeah, so it depends on the meteorite, right? Some meteorites are going to be not so expensive. Other meteorites, like really famous ones like Black Beauty, for example, are going to be super expensive. I know that's not a super satisfying answer. I can't really give you numbers, but it all depends on, how interesting that meteorite is, and in some cases, what type of meteorite it is. Okay. What are asteroid pairs? So I've never heard that exact terminology, but I'm going to guess from context clues that you mean binary asteroids, which would be two asteroids that orbit each other while they're also orbiting the sun. And LOCAMs will not exactly be looking for these asteroid pairs, but our goal is more like we see this meteor and we know because of LOCAMs that it comes from this asteroid. Therefore, with all of the observations that LOCAMs took, we can determine properties about the asteroid itself. Cool. So what got you into space and everything? Wow, you guys really want this live stream to last forever because I could talk about this for hours. But I'll just say it super briefly. You know, I got into astronomy at 14. I was in high school. I joined my local astronomy club and did, you know, night watches and all of that good stuff. But really what got me into astronomy was that I really wanted a career that changed. I wanted a career where exciting things were happening every day. And I'll tell you what, research science does not disappoint. If anybody's out there looking for a career, like, please consider research science. It is so interesting and it is so rewarding. And let me tell you, if you really dedicate yourself to research science, science will take care of you. The best way to say it. But yeah, I was just meant for astronomy. I love space. I got one that says, tell Megan to look into NASA ablation studies from previous space missions. I definitely will look into that. Thank you. I am in the Philippines. What time should I watch the meteor shower? Go out after midnight in the Philippines. In the Philippines, after midnight, go out. Wherever you are after midnight, okay? After midnight, after midnight. You in Flagstaff, after midnight. You in the Philippines, after midnight. Are you on the East Coast, after midnight? Are you in Europe, after midnight, okay? After midnight. And then also, would you recommend a 300 millimeter by 70 millimeter reflector astronomical telescope? Thank you so much. So when it comes to telescopes, you know, size doesn't really matter. Small telescopes are good and big telescopes are good. But if you tell me the brand of telescope you're looking at, that's going to matter a lot more, right? So there's, you know, higher end brands and lower end brands. Don't go to your local general store and pick up the kitty refractor telescope that's there because it's not going to work. Okay, if you're spending under $20 for a telescope, it's not going to work. Cool. Okay, and then what is my favorite part of astronomy? So this coming out of left field. I almost feel like I shouldn't say this, but I love exoplanets. Exoplanets are my favorite part of astronomy, and they're what I'm going to be studying during my doctoral program. But exoplanets, planets, and meteoritics, the study of meteors, are all very closely connected. But I can't go into that right now because you guys are making me take a lot of time to do this. So let's. I want to take some time to sort of look at the all sky camera a little bit more. So let's very briefly go through the last slides I have. Here are videos of Lyrid's meteors that I have taken last night. So the Lyrids was active last night. And you know what? Maybe this is even better than the all sky camera because I know we're going to be looking at meteors. So I'm wondering, are you guys able to see the meteors? The videos are playing now. I'll point them out in a second. I'll let you guys sort of look for yourself for a minute, see if you can find the meteors in the screen. The videos are all in loops, by the way. All right, so these are the easy ones. These are the nice bright ones. All right, I see lots of yeses in the chat. Okay, yeah, good job, guys. All right, I want to point them out. So starting with the upper left, here's the meteor. I'll let it play one more time. There she goes. Okay, on the bottom, here's the meteor. There it is. Play it again. One more time. There it is. And then in the upper right, here's the meteor. Right there. All right, so hopefully everybody can see it now that I've pointed it out. So through LOCAMs, through the observations we take, I can actually tell you beyond a reasonable doubt that all three of these meteors come from the Lyrids stream. So these are all Lyrid meteors. Now another question, is a shooting star and a meteor the same thing? Yes, it is. Yes, 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 yes. I had an astronomy professor who told me that he was conducting a sky watch one time, and somebody looked into, and I hope he doesn't mind me telling the story, I just won't say his name, but he said that he showed somebody a globular cluster, so a big cluster of stars in the sky, and they looked at him and said, when do they shoot? So I just think that's funny. But yeah, shooting stars and meteors are the same thing. They're not really stars. They're just grains of dust and rock burning up in our atmosphere. So I have a couple more meteors to show you. And these ones are harder. So really, especially the one in the lower right is really hard to catch the meteor. So we'll test your skill. They are both playing now. I'll give you guys a couple run throughs to see if you can find the meteor. And the one on the lower right, I really like to show because you guys can actually see in that image how the moon affects our observations of meteors. So the moon is obviously making it very hard for that camera to see much, if anything. Cool. So, all right, I think I give you guys enough time. I'm gonna point out where the meteors are. So starting with the easier one, right there. There she is, one more time. There she goes. And then in the moon one, which is harder, it's right over here on the side of the screen. Yeah, it's a fast one. Once again, I can confirm for you beyond a reasonable doubt that both of these two meteors are Lyrid meteors. Now we're going super fast through the rest of the slides because I am running out of time here. Here is a stack image of all of the meteors that one camera observed actually during the Perseids meteor shower last year. I just thought it was a more impressive picture, so I wanted to show you guys. But this is something that gets created every single night by each of our cameras. It stacks all of the images it sees, and you can actually see the star trails in the back too. That's fun. If you go to this website, you can actually see all the meteors that we detected here in Arizona. We actually partner with a much larger organization called the Global Meteor Network. And the Global Meteor Network has cameras everywhere, all across the world, actually. I believe it started in Croatia. And now in New Mexico, there's a lot of amateur astronomers who've been installing these cameras. So you may have noticed that we're sort of trying to establish stations here, and we're hoping that we can actually link up with them to get full coverage of this northern Arizona, northern New Mexico area. So if you want to go to this link, you can always go there and look and see how many meteors we saw just last night. And then finally, I think this is my last slide. We have been for the last year or so working on creating a super high-tech meteor science exhibit. It's using touch screens. I'm in one of the videos for it, believe it or not, super cool. I did a lot of the content development, and the super, 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 super cool thing about this exhibit is that we're gonna be feeding it the data that LOCAMS observes every single day. So every day you can go to this exhibit and see the orbits of all of the meteors that we found just last night. So this exhibit is always gonna stay current with real data that astronomers are actually gonna be using to do research. And I think that is what's so cool about this exhibit. So we're doing this with a partnership with the NAU Advanced Media Lab. And we're gonna be installing one of these exhibits at Lowell Observatory and at Meteor Crater, at the Meteor Crater Visitor Center here in Arizona. And that one, the one at Meteor Crater, will be installed as early as the end of May. So it should be really, really fun. I'm so excited to play with it. I can't even tell you. Okay. Wow, we finally got through the PowerPoint. We're gonna stop sharing. Okay, cool. So hopefully you guys have the LDT All Sky camera up on your screens now. I know I have mine up. I'm looking at it and I don't see anything that really looks like a meteor at the moment, unfortunately. But that's okay. I showed you guys videos of meteors, so we're all gonna be happy. No, I think we're really just like sort of getting to the end of this, and I know that they want me on Twitch in 15 minutes. So if I have any last questions, please, my friends at Lowell Observatory, put them in the chat. It looks like I don't have anything, so I think I'm gonna wrap this up. But if you are somehow, by some miracle, not tired of hearing me talk, then please go check out the Twitch stream, which will be starting at 10:45 Arizona time. That would be 10:45 is 11:40, 12:45. Is 1:45 a.m. on the East Coast, 10:45 Pacific time, or you can just think of it as 15 minutes from now. I'll be on Twitch with Lowell Observatory employee, my fellow friend, Hannah Zyga. So thank you guys so much. I mean, this has been a blast. And I will somehow get that time lapse to you. More likely, I will get that time lapse to my marketing folks and they will get the time lapse to you. So yeah, this has been great. Thank you guys so much. And I'm gonna wrap it up here. Have a good night and maybe see you on Twitch.